Today we'll be dealing with the simplex method minimization problem. Okay. When we take a minimization problem, initially itself we'll be converting it into a maximization problem. Okay. Because if we convert it into a maximization problem, then we can use all the steps that we used previously. Okay. Otherwise, if we are going to use different steps for minimization and different steps for maximization, then you will get confused. Okay. Negative, positive here and there, you will get confused. So that is why we are doing it in the same method. Okay, as we did the maximization problem. Okay, so we'll start. Okay, so this is our objective function and these are the constraints. Okay, and these are the non-negativity constraints. Okay, because everything should be positive. That is why we put it as greater than or equal to 0. Okay, so initially you have to start your answer. Hope you can see it. Since the given objective function is minimization type, we shall convert it into maximization type. Okay, and how do we do that? How do we do that? Minimize z is equal to minus of maximization, okay, of minus z. See, over here we have introduced one negative. Okay, to cancel that out, we have used another negative. Okay, so both will cancel out each other. Minus 1 into minus 1 is positive. Okay, so in effect, there will be no change. Okay, now I'm writing minus max of, instead of minus of z, I'm just replacing it as z star. Okay, where z star is equal to minus z. Okay, now what I'm going to do is, I'm using only this maximum of z star. No, only that I'm going to use. Okay, max z star is equal to, so instead of z star already has a negative, right? So I'm going to take that negative into the objective function. Okay, so negative of, so that is this negative. This negative is what I have put over here. Negative of, what is our objective function? Our objective function is this one. Okay, this is our objective function. So negative of x2 minus, over here I have minus 3x3 plus 2x. Can you see? I'm writing the same objective function, this one over here. Okay, the same thing. Negative of, this is this negative. This negative I have put over here. Negative of, then this is our, the first objective function that is written over here, x5. Okay, close the bracket. So what do you get? Minus x2, minus and minus will become plus 3x3 plus, sorry, this negative, when you take it over here, it will become minus of 2x5. Okay, so this is going to be our maximization objective from now on. Okay, you need to deal only with this objective. Okay, we can convert it into the, we can convert it back into the minimization type later. Okay, so just consider this maximization equation. Okay, from this you will be starting our problem. Okay. So next one, we have to rewrite the inequality of all the constraints. We have to replace with the slack variables. See over here, we have all the constraints, okay, written in the form of inequalities. Okay, when you have equality, it is called as an equation. But when you have all these types of inequalities, this full equation is called as an inequality. Okay, so over here, all these inequalities have to be converted it into equations. Okay, in simplex method, how do we do that? By adding slack variables. Okay, so less than or equal to symbol will be converted into equal to by using slack variables. Okay, we add the slack variables. Okay, so I'm writing that. We rewrite the inequality of the constraints into an equation by adding slack variables S1, S2, S3 because we have three constraints, right? Here we have three constraints. This is the first one, second one, and third one. Okay, to this I'm adding three variables. To the first equation I'm adding S1. To the second I'm going to add S2, and to the third I'm going to add S3. Okay, so S1, S2, and S3. And the standard LPP becomes, okay, subject to constraints. I'm going to start from there. Subject to constraints. The first constraint was, okay, over here you have the first constraint. No, this is the first constraint. 3x2 minus x3 plus 2x5 is less than or equal to 0. So I'm going to change this inequality into equation. Okay, so it becomes 3x2 minus x3 plus 2x5. Okay, instead of less than or equal to, I'm going to add plus s1. We don't have to put less than or equal to 7. Okay, similarly the second constraint is minus 2x2 plus 4x3 plus I'm going to add the second slack variable s2 is equal to 12. Okay, similarly the third constraint becomes 4x2 plus 3x3 plus 8x5 plus I'm going to add the third slack variable, that is s3. Okay, then it becomes equal to 10. Okay, what are the non-negative constraints there? x2, okay, we have x2 here, x2 comma, we have x3, okay, then we have x5 comma, non-negative constraints are not over because we have introduced s1, s2 and s3, so we have to add them also, s1, s2, s3 greater than or equal to 0. Okay, so since we have introduced all these variables s1, s2, s3, okay, we have to add all this slack variables into the objective function also. Okay, so the objective function will become maximum of z star. Okay, our objective function, previously our objective function was this one, right? We have made the objective function into this form. Okay, we are going to take this and we are going to add the slack variables. Okay, so over here minus x2 plus 3x3 minus 2x5 plus, okay, we are going to add the slack variable. So how will it become? It will have a coefficient of 0 because ineffective, the objective function should not have any effect. Okay, so 0 s1 plus 0 s2 plus 0 s3. Okay, so this will be our objective function. Okay, so the next step what we do is we will draw our initial simplex table. Okay, I'll show you the initial simplex table. See, so we have to take these values and then we are going to draw the initial simplex table. Okay, over here we have Cj. Cj means the coefficients of the objective function. Okay, our objective function is this one. Okay, we are going to take down the coefficients of this objective function and write it over here. Okay, so first one it is minus 1. See over here. Okay, minus 1. x3 we have 3. x5 we have minus 2. s1 we have 0. s2 we have 0. And s3 we have 0. Okay, now what were the variables? For the first one it was x2, right? So in below minus 1 I will write x2. Okay, below 3 I will write x3. Below minus 2 I will write x5. Similarly 0 I will write s1. The 0 I will write s2 and the 0 I will write s3. Okay, next over here we have basic variables. Okay, basic variable, it is represented by b. Over here we have coefficient of this basic variable, coefficient of b, that is represented as cb. Okay, over here we have solution, it is represented as xb. Okay, and over here we have the minimum ratio. Okay, now we need to find out what will be the basic variables. Okay, for that we need to write the coefficients of all the constraints over here. Then we have to check out which is the identity matrix. Okay, the identity matrix, the variables corresponding to the identity matrix will have their basic variables over here. Okay, so I'll just do it once and You can see it. Okay, so this is our first constraint. You can see the constraint over here. So I'm going to write it down. Okay, 3x2, I have the coefficient of x2 as 3. Okay, so I'm writing 3 here. Similarly, over here I have minus 1. Okay, x3 has the coefficient of minus 1. So just below x3 I'm writing minus 1. x5 has the coefficient of 2. Okay, so just below x5 I'm writing 2. Then I have s1, the coefficient of s1 is 1, and I don't have s2 and s3. So I'll put 0 and 0. Similarly, over here x2 has minus 2. So just below x2 I'm writing minus 2. Then just fill it. x3 it is 4. I don't have x5 in this equation. x5 is not there. So I'll put it as 0. Okay, here it is s2, but I don't have s1. Okay, so I'll put 0. Just below s2 I will put 1. Okay, below s3, since I don't have s3 over here, I will put 0. Okay, first one over here, the equation, the right hand side is 7. So on the first equation, I will put as 7 as the solution. Okay, second constraint, I have 10 here, so I'll put 10. Okay, now the third constraint is, sorry, over here it is 12, this 12. Okay, this 12. So yeah, I'll put it as 12 here. Okay, now I'll write down the third constraint. It is minus 4. Okay, 3, 8x5, so I'll put 8 here. S1 it is 0, S2 it is 0, S3 it is 1. Okay, and I have the right hand side as 10. Okay, now identify the identity matrix from this. I have 1 0 0 0 1 0 0 0 1. Okay, so this is going to be the identity matrix. Okay, in the first row I have a 1 here, so I'll take the variable just corresponding to that, that is S1, and the coefficient of S1 is 0. So I will be writing over here S1 and here 0. Okay, so S1 and here 0. Okay, to the second row I have a 1 over here, so the corresponding variable over there is S2 and the coefficient is 0. So over here I will be writing S2 and the coefficient is 0. Similarly, in the third row I have 1 here, corresponding variable is S3 and the coefficient is 0. So I'll be writing S3 here and the coefficient as 0. Okay, once we have done till this, we will be calculating the value of Zj. After that, we will be calculating Cj minus Zj. Zj, how do you calculate? All the numbers in the CB column. Okay, CB column multiplied by each column in this matrix. Okay, so CB into x2, okay, will form this number here. CB into x3 will form the number here. Okay, so we'll just do that. 0 into 3, 0 plus 0 into minus 2 is 0. 0 into minus 4 is 0. Okay, so all the numbers will become 0. Similarly, since we are multiplying each number with 0, everything is going to be 0. You don't have to calculate anything. See, over here we have all the numbers as 0. So even if you multiply it, everything is going to be in effect 0. So I'm just going to put 0, 0, 0, 0 and 0. Okay, next we have Cj minus Zj. This is our Cj, this is our Zj. Okay, just subtract it. Minus 1 minus 0. That is minus 1. 3 minus 0. 3 minus 2 minus 0. Minus 2. 0 minus 0. 0 0 minus 0. Here 0. Here 0 minus 0. Here also 0. Okay. So once we have got Cj minus Zj, we have to write what we have. We have number greater than 0 for Cj minus Zj, that is, we have not reached the optimality condition. Okay, so what do we need to do? For getting an optimality condition, all the numbers over here should be either 0 or a negative number. Okay, but in our case, here we have positive 3. Okay, that so by this we understand that we have not reached the optimal condition, or this is not our final simplex table. This is not the final simplex table. We have to further iterate. Okay, for that what should we do? We have to find out what? The outgoing vector Okay. We have to find out the outgoing vector. We have to find out the incoming vector. Okay. And the key element. Okay. After that, we have to perform certain row operations. Okay. So how do we find out the incoming vector? Okay. From Cj minus Zj value, here we have a positive 3. Okay. So this is going to be our key column. Okay. This much is going to be a key column. And over here, x3 is going to be the incoming vector. Okay. So x3 is going to be the incoming vector. Next, we need to find out which is going to be the outgoing vector. For finding the outgoing vector, we have something called as the minimum ratio. Okay, minimum ratio. So how do we take the minimum ratio? It is xb divided by, xb is this column. Okay, xb is this one. Okay, divided by, we have found out our key column is going to be x3. Okay, so xb divided by x3. So how do we do that? 7 divided by minus 1, which is minus 7. Okay, in our case, we'll be taking only least positive value for minimum ratio. So in our case, this is negative 7. So you just put a dash there. We don't have to consider this number. Okay, next one. 12 divided by 4. 12 divided by 4, which is 3. Okay, next one. 10 divided by 3. Okay, 10 is this one divided by 3. You will get it as 3.33. Okay, so which is the minimum value here? We have 3 and 3.33. So the minimum of both these values is 3. The least value is 3. So we'll have to consider this as the key row. Okay, this is going to be the key row. This is going to be the key element. Okay, and S2 is going to be the outgoing vector. So in the next simplex table, instead of x2, we will have the value x3. So this x3 value will come down here and the coefficient of x3 is 3. So instead of this 0, we will have this 3. Okay, so next, what have we found out? So our outgoing vector is S2 and incoming vector is x3. Okay, outgoing vector is S2, incoming vector is x3, and our key element is 4. Okay, key element is 4. Okay, after this, we have to perform certain row operations. Okay, what are the row operations? Perform following row operations. Okay, what do we need to do? In this is the key row. Over here, we have the key element as 4. We need to make this 4 as 1. Okay, in the next simplex table. For that, we have to divide all the numbers in this row by 4. Only then this 4 will become 1, right? 4 divided by 4, it should become 1. So for that, you should not only divide this 4 by 4. We have to divide all the numbers in this row by 4. Okay, so what are the numbers here? Our equation will become, this is R2. Okay, so R2 new will become R2 old divided by 4. Okay, what are the numbers there? -2, 4, 0, 0, 1, 0. Okay, -2, 4, 0, 0, 1, 0. And in the solution of this column, I have 12. Write down 12 also. Okay, I have written down 12 also. Now, we are going to divide by 4. What is the answer? -2 divided by 1 by 4, it will become -1 by 2. Okay, this will become 1, this will become 0. Okay, just before that, I'll tell one more thing. 0 divided by 4, we have 0. Okay, but 4 divided by 0, it is not defined. Okay, this is not defined. Any number divided by 0, it is not defined. 0 divided by any number, it is 0. Okay, if it is not defined over here, then you will need to just put a dash there. Okay, coming back, 0 divided by 4, it is 0. 1 divided by 4, it is 1 by 4. Over here, it is 0. And over here, we have 12 divided by 4, which is 3. Okay, that is only, we have changed only R2. R2 new becomes this way. So we have to first do the row operation for the key row. Okay, our key row was R2. That is why we changed R2 first. Okay, and R1 and R3 will have the influence from the new key row. That is why we are changing the key row first, and only then we will go for the R1 and R2. Okay, so how will your R1 change? How is R1 going to change? Okay, so R1 new is equal to R1 old minus, okay, which is the number above or below the key element. Over here we are considering the first row, so we have to consider the number above the key element. Key element is 4, above is, it is minus 1. So I'm writing minus 1 into R2 new. Okay, always be careful. Here it is the new row. You don't have to take R2 old from this old table. This is the old table. You have to take the R2 new from the values that we just found out. We did one row operation, right? Divided by 4. So that those values is what we have to consider. Okay, so just take down R1 old from this old table. We have 3 minus 1, 2, 1, 0, 0 and finally 7. Okay, minus of minus 1 into, I'm just writing it down. Okay, now R2 new, we already have those values, right? See, these are the R2 new values, minus 1 by 2. Okay, over here, minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. Okay, so just do this. 3, here we have minus into negative into negative. 3 negative, we have in effect a negative number. Okay, 1 into 1 by 2, we have 1 by 2. Okay, which is equal to 3 into 2 is 6 minus 1 divided by 2, which is 5 divided by 2. The same answer you will get it in the calculator. Okay, we have already discussed how to do that. Say 3 minus 1 by 2. 3 minus, better you put brackets. Okay, otherwise sometimes it can go wrong. So 3 minus, you put a bracket. Okay, here 1 by 2, it is one digit, right? So I'm putting 1, then the block over here. Okay, by 2, which is 5 by 2. Okay, so same thing over here, I get 5 by 2. Better you use the calculator, otherwise you might make mistakes. Okay. Next one, minus y, minus 1, negative into negative, it is plus 1, which is 0. Minus 1 into plus 1, which is 0. Okay, 2, here minus into minus, which is plus 1 into 0. It is 0, which is 2. Again, here we have multiplication by 0. So in effect, it becomes 1. This one only we need to consider. Again, 0 minus, here we have negative into negative, which is equal to positive. Then we have 1 by 4. Here we have 0. Okay, 0 minus 0, which is 0. And here we have 7. Minus into minus is plus. 1 into 3 is 3, which is equal to 10. Okay, the next one we have to change for R3 new is equal to R3 old minus, which is the number above or below the key element there. We are considering the third row. Over here, the key element is 4. So when we are considering third row, we have to consider the number below the key element. Okay, that is 3. Okay, so over here I have 3 into R, which is our key row. Key row is the second row. Okay, so the new R2 new is what we have to consider. Okay, just write down what are the R3 old values. It is minus 438,001. Okay, minus 438,001. Again, you have to minus 438,001, and you have to consider this number also. Okay, so it is 10. Minus of 3 into okay, now R2 new, what are the values of R2 new? We have already found out over here. Okay, it is minus 1 by 2. I'm writing down these values. Minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. Okay, Solve for getting each of these values. Minus 1 by 4. Here we have a negative. See, here we have a negative. Negative into negative, which is positive. I have 3 by 2. Okay, which is minus 8 plus 3 by 2, which is equal to minus 5 by 2. Okay, same thing you will get in the calculator. Just do and see. Minus 4 plus 3 divided by 2. Okay, it is minus 5 by 2. Now, 3 minus 3, which is 0. Now, 8 minus 0, which is 8. Okay, next one, 0 minus 0, it is 0. Over here we have minus 3 by 4. Over here we have 1 minus 0, which is 1. 10 minus 9, which is 1. Okay, so we have got all the values. Substitute it in your second iteration table. Okay, this is our first iteration table. Over here we have the values of Cj. Cj will remain the same because objective function, the coefficients of the objective function will remain the same. Okay, so here we have Cj. I'm going to write down the same values. Minus 1, 3, minus 2, 0, 0 and 0. What are the variables corresponding to it? It is x2, x3, x5, s1, s2 and s3. Okay, over here we have basic variable b. Over here we have coefficient of b. Over here we have solution, that is xb. Okay, here we have the minimum ratio. Okay, and we had found out the incoming vector and the outgoing vector. Okay, over here the outgoing vector is going to be s2. So instead of s2 we will be writing x3. Okay, so in the second row I am writing x3. What is the coefficient of x3? It is 3. Okay, the other numbers will remain the same, 0 and s1. So here 0 and s1. In the third row I have 0 and s3. So here I have 0 and s3. Okay, now I'm going to write down the new values of R1, R2 and R3. R1, see, we did R1 over here. Don't make a mistake, we did the key row first. Only then we jumped into calculating R1. Okay, so you have to write R1 first and then the key row operations and then R3. Okay, so here we have R1 new is equal to 5 by 2. Just tell me the values. 5 by 2, 0, 2, 1, 1 by 4, 0 and 10. Okay, so I have written all the values there. Okay, 5 by 2, 0, 2, 1, 1 by 4, 0 and 10. Next we have R2 new. R2 new is our key row. Okay, key row operations we have done over here. Just writing down the values. Minus 1 by 2. Can you see? Okay, minus 1 by 2. Here I have 1. Then 0, 0. 1 by 4, 0. And here I have 3. Okay, next is R3. R3 value I've got back in this one. Okay, can you see R3 new? R3 new, it is minus 5 by 2. Then I have 0, 8, 0. 0, 8, 0. Then minus 3 by 4. Okay, then 1 and 1. So 1 and final one over here. Okay. Okay. Next, what do? We have to go for Zj and Cj minus Zj. Okay. So calculate Zj. How do we calculate Zj? Each value in CB multiplied with each column in the matrix here. Okay. So 0 into 5 by 2 plus 3 into minus 1 by 2 plus 0 into minus 5 by 2. Both here and here we have 0. So we don't have to consider those numbers. Only we need to consider is 3 into minus 1 by 2, which is minus 3 by 2. Similarly, over here, we need to consider 3 into 1 only, that is 3. Over here, this number is 0. 3 into 0 is 0. 0 into 8 is 0. So together we have 0. Here 0 into 1 is 0. 3 into 0 is 0 plus 0 into 0, that is 0. Then again 0 into 1 by 4, 0. 3 into 1 by 4, that is 3 by 4 plus 0 into minus 3 by 4, it is 0. So only we need to consider 3 into 1 by 4, that is 3 by 4. And over here 0 into 0 plus 3 into 0 plus 0 into 1, which is 0. Okay, next we need to consider Cj minus Zj. You can calculate this value for the solution part also. Okay, so 0 into 10 is 0 plus 3 into 3 that is 9. Okay, plus 0 into 1 that is 0. Okay, so here we have 9. Okay, in this table, what is the value of Z star? This will be the value of Z star. Okay. Next one, Cj minus Zj. How do you calculate? This is our Cj, this is our Zj. Subtract it. Okay, minus 1 minus. Okay. Here I have minus 1 minus of. Okay, Cj minus Zj, this minus. Okay, that is this one. Into Zj value is minus 3 by 2. So I have minus 3 by 2, which is minus 1 plus 3 by 2, which is minus 2 plus 3 by 2, which is 1 by 2. Okay, is it clear? This is how we get the value of here. Okay, next one, 3 minus 3, that is 0, minus 2 minus 0, that is minus 2, 0 minus 0 is 0, 0 minus 3 by 4, it is minus 3 by 4, 0 minus 0 is 0. Okay, so can you tell me, is this the optimal value? Have we reached the optimal value? In this one, we have not reached the optimal value because Cj minus Zj, here we have a positive value. Okay, we should reach all negative or zero numbers so that we can reach the optimality condition. But in this table, we have not reached the optimality condition because over here we have the value as a positive one. Okay, so we will consider this as our new incoming vector. Okay, and after that we have to find out the outgoing vector. For finding the outgoing vector, we have to calculate the minimum ratio. Minimum ratio, how do we calculate over here now? XB divided by, this is going to be the key row, sorry, key column. So divided by X2. Here we have X2, so I am dividing it by X2. Okay, so 10 divided by, instead of divided by 5 by 2, okay, I can write here 5 multiplied by 2 on top. Okay, so that is going to be 10 and 5 we can cancel. Okay, here we have 2 into 2, which is 4. Okay, next one, 3 divided by here minus 1 by 2. So minus 1 into 2, which is minus 6. Okay, it is a negative number. You don't have to consider negative numbers for minimum ratio. Just put a dash there. Okay, next one, 1 divided by this 1 divided by this number, minus 5 into 2. Again, it is a negative number. Okay, minus 2 by 5. You don't have to consider. Okay, minus 2 by 5. Just put a dash. Okay, so you have only one positive value. So this will be the key column. Okay, and this is going to be the S1 is going to be the outgoing vector. Okay, in the next simplex table, instead of S1, we will have the value of S2. Okay, so instead of 0, we'll have the coefficient of X2, that is minus 1. Okay, so over here we have the key element as 5 by 2. The intersection of these two, we have 5 by 2. 5 by 2 is going to be the key element. Okay, so just theory part, you are writing all Cj minus Zj is not 0 or less than 0. So we have not reached the optimal solution. We find out what are the things that we are finding out. The outgoing vector. The outgoing vector will be which value here? Outgoing vector is going to be S1. Okay. S1. The incoming vector is going to be X2. X2. And we have the key element. Key element is the intersection value, that is 5 by 2. Okay, once we have done this much, we have to do the row operations. Okay. Okay, row operations, perform the row operations. Here we have the key row is the first row. Okay, so R1 new is equal to R1 old divided by 5 by 2. The key element is 5 by 2. So write down the elements of R1 old. Okay, that is 5 by 2, 0, 2, 1, 1 by 4, 0 and 10. Okay, instead of divided by 5 by 2, I am writing multiplied by 2 by 5. Okay, so everywhere I am writing it as 2 by 5. Okay, here 2 and 2 cancel, 5 and 5 cancelled. I have 1. Here I have 0. Here I have 4 by 5. Here I have 2 by 5. Here I have here 2, 4 and 2 cancelled. It is 2 over here. 2. So 2 into 5, that is 1 by 10. Here I have 0. Here I have this 5 and 10 cancel. 2. 2 into 2, that is equal to 4. Okay. Next one, I have R2 new is equal to R2 old minus the number above or below the key element. When we are considering the second row, the number below the key element is, when we are considering the second row, the number below the key element is minus 1 by 2. Okay, so I'm writing here minus 1 by 2 into R1 new. Okay, R1 new is the key row. So I'm writing R1 new. Okay, what are the elements of R2 old? R2 old, it is minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. So I'm just writing it down. Okay, minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. Okay, minus of minus 1 by 2 into, I'm just copying it everywhere. Okay, now R1 new. R1 new. Yeah, R1 news this value itself. R1 news this one. So you have to write down all these values. So 1, 0, 4 by 5, 1, 0, 4 by 5, then 2 by 5, 1 by 0, sorry, 1 by 10, then 0 and 4. Okay, what are the values? Minus 1 by 2, minus of 1 by 2. So it is minus 1 by 2, minus into minus, it is plus 1 by 2, which is 0. Over here, there is a 0 here. So this entire number becomes 0. 1 minus 0, it is 1. Over here, minus and minus, it will become plus 1 by 2 into 4 by 5. Okay, we have to cut over there and becomes 2 by 5. Okay. Again here minus and minus, it will become plus. Okay, here we have 1 by 5. Next one. Here I have 1 by 4, minus and minus I have plus. Okay, becomes 1 by 20. Okay, LCM will be 20. Just do it in the calculator. 1 divided by 4 plus 1 divided by 20. Okay, we have, 1 divided by 4 plus 1 divided by 20. It is 3 divided by 10. Okay, 3 divided by 10. Here 0 minus 0, which is 0. Here 3 minus and minus, I have plus. Here I have 2. Okay. See, here I have 2. Okay. Is equal to 5. Next we need to find the values of R2. R3 new. Okay. So R3 new is equal to R3 old minus, what is the number above or below the number over here? It is minus 5 by 2. Okay, so it is minus 5 by 2, minus 5 divided by 2 into, okay, R1 new. Okay, just tell me the values of R3 old. R3 old, it is minus 5 by 2, 0, 8, then 0, minus 3 by 4, 1 and 1. Okay, 1 and 4. Minus of minus 5 by 2 into, okay, okay. Now R1 new. What are the values of R1 new? We had found over here. That is 104 by 5, 104 by 5, then 2 by 5. Can you see? 2 by 5, 1 by 10, 0 and 4. 2 by 5, 2 by 5, 1 by 10, 0 and 4. 2 by 5, 1 by 10, 0 and 4. Okay. So here we have minus 5 by 2, minus and minus, it becomes plus 5 by 2, which is 0. Next one, 0 minus 0, which is 0. Here I have 8 minus, over here 5 and 5 cancelled. Okay. Here I have 2. Negative into negative, it becomes positive. So positive 2, which is 10. Okay. Yeah. Next one, over here, minus and minus, we have positive. Over here, 5 and 5 cancel, 2 and 2 cancel, we have 1. Next, minus 3 by 4. Here negative into negative, we have positive. Okay. 5 and 10 cancelled 2. That is 1 by 4. Which is minus 2 by 4, which is minus 1 by 2. Okay. Now next one, it is 1. This one, 1 minus. So it is minus into minus, it is plus. Okay. We cancel 5 into 2. It is 10, which is 11. Did you see that? Okay, we have all these values. Now substitute them in the next iteration table. Okay, we have the iteration table 2 here. So again, Cj, the coefficients of Cj will remain the same. Okay, just write these values. Okay, these values will come over here. Minus 1, 3, minus 2, 0, 0 and 0. The variables below that will also not change. 5, S1, S2 and S3. Okay, here we have the basic variable. Here we have the coefficient of the basic variable. Here we have the solution, that is XB. Okay, here we have the minimum ratio. Okay, now we have to consider which is going to be the outgoing vector, which is going to be the incoming vector. Here outgoing vector is S1. Instead of that we have X2. Okay, so X2, the coefficient of X2 is minus 1. So I write minus 1 here. The other variables are going to be the same. So 3 and X3. So I write here 3 and X3. And here we have 0 and S3. Okay, 0 and S3. Okay. Now we have to write the new values of R1, R2 and R3. Okay. Here we have R1 new. Okay, so 1, 0, 4 by 5. 2 by 5, 1 by, can you see? Okay. 2 by 5, 1 by 10, 0 and 4. Okay. R2 new, values of R2 new, 0, 1, 2 by 5. Okay, 1 by 5, 3 by 10, 0 and 5. Okay, I have written all the values here. Next is R3 new. Okay, R3 new I have 0, 0, 10, 0, 0, 10, then 0, 0, 10, 1, minus 1 by 2, 1, 1, minus 1 by 2, 1, and the last value is 11. Okay, so 11 here. Once we get so much, we have to calculate the value of Zj. Okay, what is Zj? All these CB multiplied by x2. Okay, similarly CB multiplied by x3. Okay, how do you, and you have to complete it. How, so tell me the values. Minus 1 into 1 plus 3 into 0 plus 0 into 0. That is minus 1. Next one. Here we have a 0 here, so we don't have to calculate. 3 into 1, that is 3. Next one. Minus 1 into, here I'll take it down, this value. Okay. Minus 1 into 4 by 5. Can you see? Okay. Minus 1 into 4 by 5 plus 3 into 2 by 5. 2 by 5 plus here 0 into 10. That becomes 0. Now this is equal to minus 4 by 5 plus 6 by 5, which is equal to 2 by 5. Okay. Just give me a second. Yeah, 2 by 5. So here I write 2 by 5. Over here, again I'll take that value down and write it. Okay, here I have minus 1 into 2 by 5 plus 3 into 1 by 5 plus 0 into 1. I don't have to calculate. Becomes minus 2 by 5 plus 3 by 5, which is equal to 1 by 5. Okay, next value. Okay, so this one also I will take it down. Yeah, were you able to see that? This is the previous value. Now the next one is, okay, minus 1 into 1 by 10. That is minus 1 by 10 plus 3 into 3 by 10. 3 into 3 by 10 is 3 into 3 by 10, which is 9 by 10. Okay, do it. Okay, you will get 8 by 10, which is equal to 4 by 5. Okay, so this value will be 4 by 5. Next one, minus 1 into 0 plus 3 into 0 plus 0 into 1, which is 0. Okay, now again you can calculate for these values also. Okay, so minus 1 into 4 plus 3 into 5 plus 0 into 11. That is how much it is? Minus 4 plus 3 into 5, that is 15. Okay, over here you will get the value as 11. So in this simplex table, the value of Z star is 11. So that is the meaning. Okay, the value of Z star is 11 from this simplex table. Now next one, Cj minus Zj, since we need to calculate the optimality. We need to check the optimality. Okay, so this is Cj, this is Zj. 1 minus of minus 0. What is the value? Minus 1 minus of this minus is this minus. Okay, minus of minus 1. So what is this? Minus 1 plus 1, which is 0. Okay, now 3 minus 3, 0, minus 2 minus 2 by 5. What is the value? Minus 2 minus 2 by 5. Which is minus 10 minus 2 whole divided by 5, which is minus 12 by 5. Okay, next one, 0 minus 1 by 5, that is minus 1 by 5. 0 minus 4 by 5, that is minus 4 by 5. 0 minus 0, which is 0. Okay, now tell me, check the optimality condition and tell me over here we have, this is 0, 0, minus 1, 12 by 5. Here again minus 1 by 5. Here we have minus 4 by 5. Here we have 0. Okay, all the values of Cj, it is either 0 or it is, which one? Either 0 or it is a negative number. So we have reached the optimality condition. Okay, I'll write it over here. Since all Cj minus Zj is less than or equal to 0, the above solution is optimal. Okay, above solution is optimal. So tell me the values of x2, x3 and x5. x2 it is 4. Okay, x3 it is 5. What is the value of x5? Do we have x5 here? We don't have x5. So we can take, instead of x5, we can take 0. Okay, the value of x5 will be 0. Okay, so x2, we got 4. I'm writing it down. x2 is equal to 4. x3 is equal to 5. And from this table, we don't have x5. Okay, so I'm taking it as 0. x5 is equal to 0. Okay, we don't have to consider this S3 and all. Okay, all this comes as part of the iterations. Okay, otherwise we don't have to consider S3. Okay, because these are the values that we introduced, right? S1, S2, S3 are the values that we introduced. So we don't have to consider this one. Okay, we need to consider only the values of X2, X3 and X5 in this case. Okay, so we got this one. Now, and our Z was Z star value we got as from the table, we got the value as 11. Okay, so that is 11. Okay, now we need to check the answer, right? How do we check the answer? In our initial objective function. Okay, substitute these values there. Okay, what is our initial objective function? Okay, can you see? I'm taking this as equation number 1. So substitute all these values in our initial objective function. See, this is the objective function which we got after multiplying with that minus value. Okay, max of Z star is equal to, we did one equation over here. No, this is the objective function which we got after multiplying the objective function with minus 1. Okay, so in this equation we have to substitute the values of x2, x3 and x5 for checking the answer. Clear? Okay, so I'm going to take down the value of objective function. Our Z maximize Z is equal to Z star. Actually, it was Z star, right? Maximize Z star is equal to negative x2, that is minus x2 plus, okay, 3x3 plus 3x3 minus 2x5. Okay, this is minus 2x5. Okay, substitute the values of x2, x3 and x5 in this equation. Okay, this is equation number 1. Substitute these values. We have negative of, this negative is written over here, x2. x2's value is 4. 4 plus 3 into, what is x? Sorry, here it is x3. What is 3 into x3? That is 3 into x3 is 5. Minus 2 into, here we have x5. x5 we have 0. Okay, 0. Which is equal to minus 4 plus 15. Which is minus 4 plus 15 is 11. See over here, we got the value as 11 after substituting it in the basic objective function. Same value we got it from the table. See over here, we have the table. These are the table values. 11 is our Z star value. Okay, so we understand that what we have done till now is correct. Okay, with this our solution does not end. We have to return the value back to the minimization problem, right? Okay, what was our minimization problem? Minimize Z is equal to, this is what we wrote over here, right? See, what did we write there? Can you see? Minimize Z is equal to minus of max of Z star. Okay, I'm writing that over there. Okay, minimize Z is equal to minus of max of Z star. Max of Z star is 11. Okay, this 11 that we got is max of Z star. See over here, this is the value. Max of Z star is 11. So I'm substituting minus of, instead of max of Z star, this is this minus. Okay, instead of max of Z star, I'm substituting it by value 11. Okay, so 11. So what did we get? Minimization Z is equal to minus 11. Minimization Z is equal to minus 11. Okay, so this is going to be our solution. Is it clear? Minimization Z is equal to minus 11, comma, x2 is going to be 4, x3 is going to be 5 and x5 is going to be 0. All these values will remain the same. Only for minimization Z value, you need to put that negative sign back. Okay, so this is going to be the solution.